Alright, this video is for exam 4, page 2, section 1, and we will be starting right now. So the question asks us to evaluate the following indefinite integrals. So right here at A, we have integral of 4x to the power 6 minus x to the power of 3 plus 1 over x minus 3e to the x dx. So we can make define the integral part of it easier by rewriting our equation into 646x minus x squared minus 1 over x minus 3 e to the x dx, because this part of the equation is the same as this part of the equation. So now we could take our integral. So 4x to the power of 7 over new power, which is 7, minus x to the third power over the new power, which is 3, minus ln of absolute value of x, because 1 over x, the derivative of ln is 1 over x. And finally, e to the x is always e to the x. The 3 is in front of the x, and so of e to the x. So it works as basically when you take the derivative, you move this one outside of when you split up the integral into each individual part. So the integral, it will be -3 times integral of e to the x. So our answer will be e to the x. And finally, we need to add our c, because when we take an integral, there might be some stuff that might be missing when we took the derivative, so we add plus c. And that is all for part A. Next part is part B. So the antiderivative of cosine x is sine x, because derivative of sine x is cosine x. Next up is negative CSC of x times cotangent of x, and that would be CSC of x, because the derivative of CSC of x is negative cosecant times cotangent. Next up is negative 1 over 1 plus x squared. And this one is a bit tricky to tell because it looks similar to an logarithmic function, and taking that looks similar to this, but it's actually a inverse trigonometric function, and more specifically, it could be either negative inverse tangent of x, or it could either be cotangent of x, because inverse of cotangent of x, because inverse of cotangent of x is negative 1 over 1 plus x squared. We'll do in this case tangent of inverse tangent of x. But it could be also positive inverse cotangent of x. And finally, pi. And if you pay close attention, you'll know that pi isn't a variable. Pi is just a constant number. So in this case, it'll be the integral will be pi x. And finally, we need RC. And so our answer to B is now finished. Next up, C is integral of 2x times 4 minus 6x all to the power of 5 dx. Now this one is a lot trickier because we have multiple uh, multiple x's. However, we'll use the u sub function. So for this one, we will let u equal to 4 minus 6x. And then we'll take the derivative of u, which is du equals negative 6. And next step is to, well, we also have dx here. So next step is to isolate 6x. So we'll have du over negative 6 equals dx. And that is the first part of our equation. So we will rewrite this equation and replace u minus 6x with we'll replace 4 minus 6x with u. So 2x times u to the power of 5, and we will also replace dx with du over negative 6. So times du over negative 6. Now, as you can see, we are still missing a bit of stuff. So we still have our x. We'll deal with that a bit later, but first we can simplify this a little bit by taking this division and dividing by 2, and then we'll be left with negative 1/3. And then, and with that negative 1/3, since it's a constant, we can move outside of the function since it's being multiplied with the rest of the equation. So we can simplify this to negative 1/3 in integral of x u to the 5th power du. Now, we have simplified our function a little bit, but we still haven't solved the problem that we have two different variable types. So, in order to solve that, we will go back to our u equals 4 minus 6x, and we will actually solve for 6x, so we can replace u with what x equals to. So in this case, u equals 4 minus 6x. So u minus 4 equals negative 6x. And so with that, x will equal to u minus 4 over 6, negative 6. And so we can now replace this we can replace now x with what we have instead right here so we can get u, and our function only has one variable type. So let us do that right now. Negative 1/3 of root of, let's negative 6 of u power 5 du. Now, next step is that we could actually take this divided by 6, because we could just have a -1/6 times u minus 4. So we could also take that out and multiply it with the -1/3. And so we will get, zoom in to have a bit more space, 1/18 interval of u minus 4 times u to the 5th dq. And now the easiest way to do the rest of the problem would be to uh, multiply these two together. So 18 interval of u to the 6th minus 4 u to the 5th du. And now we take our interval of this. So we will have 1/18 of u to the 7th over 7 minus 4 u to the 6th divided by 6 plus c. And we could simplify this down, and when we multiply it by 1/18, we will get u over 7 1/26 minus u to the 6th over 27 plus c. And now the final step is to replace u with our original, well, 4 minus 6x. So our final answer will be x to the power 7 over 126 minus 4 minus 6x to the power of 6 over 27 plus c. And that is our final answer for C. And now finally for this page, the integral of e to the power of root x over root x. So the first step is to do similarly to the previous problem, and in this case we will let u equal root x. And so we will then solve for u. Du equals 1 over 2 root x dx. And so we will solve for dx, which is 2 root x du equals dx. So we will go back to our integral and rewrite it as e to the u. Whoops, sorry, I almost forgot the second. And in this case, we will not let our root the x at the bottom be replaced with u because we want to cancel those first. So these two get canceled, and we're left with e to the u times 2 du. And so the 2 can be taken out, and so we then have 2 integral of e to the u du. So now we take our integral, and e to the u is e to the u, because that's how e to the x works, and u is our variable in this case. So we're going to have 2 e to the u plus c. And so now all we have to do is replace u with root x. So now our final answer will be 2 e to the root x plus c. And that is the final answer for page 2. Alright, I hope that's all, and I hope you are all doing well. Alright, goodbye.